Hello, 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 hello.
Hi, hello.
Hi, Sammy. How are
I
you?
think you can start anytime.
Hi,
Yeah,
Sammy. How are you?
yeah, I'm fine. Yeah,
Yeah. Shall I start? Yeah. Shall I start?
yeah. I think we can start now. Yeah.
Yeah. Thanks. Yeah. Thanks. Yeah. Good evening, everyone. I'm excited to present my talk at PyCon Hong Kong 2020. My topic will be deceptive security using Python. And to introduce myself, my name is Gajendra Deshpande, and I am working as assistant professor in the Department of Computer Science and Engineering at KLS Gupta Institute of Technology, India. So, in today's talk, I will be discussing about introduction to deception, then web trap software, demon hunter software. So, I'll be giving very brief introduction about these two tools. Then, lastly, our experiment, whatever tool we have developed. So, about that, we will focus more. So, how we have developed it using Python, then conclusion and references. So, before starting, let me introduce or briefly tell a story which will tell you what is meant by a deception. So let's imagine you are passing through an unknown road at midnight and you find that there are some antisocial elements and they are following you and you feel unsafe to walk there. So to save yourself from them, you may start running or you may look for some safe place to hide yourself. So on the way, you will find a good person or a home where you can take shelter and you may request the homeowner to help you. So the homeowner will hide you in his place to protect you. So when these antisocial elements visit that person's home and inquire about you, that person misguides them and redirects them to some other place in order to protect you. So this is exactly how a deception works. So in this analogy, you are the resources to be protected and antisocial elements are the hackers who want to gain access to the resources. And a good person is a deception technique that protects the resources from the hackers by making them fall in the trap. So the basic idea of deception is it's the technique used by hackers basically to attack the resources. For example, phishing can be considered as a deception technique. So in phishing, what happens is the attacker creates a website whose interface looks like genuine website, but actually it's the fake one. For example, a banking website. So it may look like a genuine website, but actually it's not a genuine website, it's a fake website. So some general users or those users who are not technologically savvy, they may easily fall prey to such tactics. They may feel that the fake website itself is a genuine one and they may enter all their details. So once they enter all their details, the attacker will get all the data. So this is this is a technique used by attackers to gain access to the people's information or access to their machines. and further they can be exploited. In deception, we are going to use the same mechanisms used by the attackers, but to protect the resources. So deception can also be thought, or traditionally it's a military tactic used by both attackers and defenders. So attackers generally what they do is they try to deceive their enemies by putting some false resources so that the enemies can fall to their trap. So similarly, the defenders can also use the similar tactic to defend themselves. Now, if you see the diagram, this diagram explains how deception technique works. Now you can see here there are two types of users. One is the benign user and second one is the malicious user. Now both of these users they access the common interface, and when authorized user accesses the common interface, he will get the normal access to the real system because he will not be giving any illegal inputs. So he has very limited input vector, so he knows exactly, or he has a limited knowledge of inputs. So here the possibly he may just enter his mobile number or email id and password to gain access to the real system. Now if we come to the malicious user, he may not just enter his username or a password, instead he may enter some malicious inputs. So in that case, what system will do is system will not give him the access to the real system. Instead, it will redirect the access to the deceptive system. So in this way, the real system can be protected by the malicious user. Now deception types. There are two types of deception technology. So one is active deception and second one is passive deception. In active deception, what happens is inaccurate information will be intentionally provided to the hackers. Now this can be a false information, this can be complete information also, but it will be inaccurate information. Then second one is the passive deception. In passive deception, incomplete information will be provided to the hackers. So while the hacker is figuring out the other half of the information, the security guys can try to protect their real resources. Now these deception types can also be classified as client-side deception and server-side deception. So client-side deception is used by hackers. So as I've already explained, it is nothing but a phishing attack. So that's a client-side deception. Then the same mechanism can be used by security professionals on the server side. So where they may provide inaccurate information or incomplete information while the hacker is busy in dealing with the incomplete or inaccurate information, they may secure their resources. Then what is the better approach? The better approach is to use active deception as well as passive deception together so that you can provide inaccurate information as well as incomplete information. So in this way you can engage the hacker in activity and you will get more time to protect your resources. Now the first deception technology was the honeypots. So they were introduced in the year 1998. So after that, honey nets came in 2000. The honey token came in 2003. Then honeypot version 2.0 in 2012. Then the deception technology in 2016. But actually, we started working on deception much earlier. So honeypots are like network devices where they will be installed on a network, so only legitimate users know about the network. They are like traps, and honeypots are like they are having a information which may look attractive to the attackers, because they may feel that okay, this information is accessible here, I can easily access it. But when they try to access it, it will be reported to the server. So in this way honeypots work. Now there are some advantages the deception technology provides. The first one is increased accuracy. So increased accuracy because in other technologies you only concentrate on false positives, but here we also concentrate on false negatives. So that's why there is an increased accuracy. Then minimal investment, because you don't need much high technology hardware, so you can use software or existing technology. And one more thing is, even if the new technology comes, the same infrastructure can be used to protect your resources to implement a deception mechanism. Okay, that's the advantage here. And future ready, say for example there are attacks over databases in terms of SQL injection attacks. So after SQL, XML came. So in XML there were XPath injection attacks. So whatever rules hold true for SQL injection attacks, so they also hold true for um, XPath injection attacks. So it is future ready. So even if the new technology comes tomorrow, but still it's going to work. You did not have to make much modifications, or you do not have to invest much in implementing deception technology. Now let me introduce briefly the web trap software. So it is available at the below given GitHub repository. So it is basically designed to create deceptive web pages to deceive and redirect attackers away from the real websites. Now the deceptive websites are generated by cloning real websites, specifically their login pages. Now if you observe here, it's the same thing which hackers do while performing phishing attacks. But here we are using the same thing but for protection of our resources. Now this WebTrap project consists of two parts. One is the web cloner, which is responsible for cloning real websites and creating a deceptive web page. Then second one is a deceptive web server, which is responsible for serving the cloned web pages. Note here that it serves the cloned web pages, not the real web pages. And if anybody tries to access the cloned web pages, it will be reported to the server on the request. Now to install, you can use pip command and you can install following packages. Now to successfully install this on your machine, you need Ubuntu 16.0. If you have Ubuntu 16.0, this will work without any problem. You will be able to successfully install it. But if you try to install it on higher versions of Ubuntu, say Ubuntu 20 or Ubuntu 19 or 18, you will get an error related to Python GI package. So you need to resolve it. So once you resolve it, it may work on other systems also. But as of now, even the authors are claiming that they have tested on only Ubuntu 16. So it works on Ubuntu 16. So I tried it on higher versions, but there are issues with respect to Python GI package. So once you resolve it, you can easily install and work on it. So this is how you need to use web cloner package. So you need to run a file called as webcloner.py from the repository. So you need to specify the output directory and you need to specify the website URL. So website URL is nothing but the URL of the login page, and the output directory is nothing but the directory where your login page and associated files will be cloned. Now following is the example. So you can see here the command has been used Python, then we are using webcloner.py script, then we are using the output -o switch for the creation of the directory, output directory, and we have specified the URL of Wikipedia page. You can specify any page, but specifically or it should be the login page. So once you specify the login page, the entire login page will be downloaded and it will be stored in Wikipedia login page folder. Of course, you can change it to any name. So that's output folder. Then once you clone your page, you can also run a deceptive web server. So to run a deceptive web server, you need to make use of a file called as trapserver.py file from the repository. So here you need to specify from which file, from which folder you want to serve the pages. So here in the example you can see -d switch is used and output folder name is specified. So that means from this folder files will be served. Now you can also report the errors to the server, but you need to configure a log server. So whatever activity take place on these login pages, they will be reported to the syslog server. Now the next tool is the daemon hunter. So it's basically a honeypot server and it follows master and agent architecture. Now what happens here is there are servers and there are agents, and also there is a manager to check the logs. Now it allows you to create your own honeynet for all. It allows you to create your own honeynet and you can customize it to your requirements. That means you can use your own ports and you can use your own protocol handlers. Now here in the architecture you can see there are 4 honey agents and at the center there is a manager. Now you can see here each of the honey pot is using different protocol. For example, first honeypot is using only protocol 1, second honeypot is using 2 protocols, protocol 1 and protocol 2, but the third honeypot is using a separate second protocol but with a different handler, and last one is using the third protocol. Now protocols can be like you can use a FTP protocol or you can use telnet protocol, and you can use mixture of these protocols at a time, and you can set up your own server here. For example, if you want to use this with Apache server, you can use it. If you want to use it with Microsoft IIS server, you can use it. So basically this is also the same where traps are set up. These honeypots are nothing but different traps. When attacker tries to access it, it will be reported to the manager. So next is why we developed the our own deception tool. So our idea was to develop a deception tool for web applications. So we consider, or generally cyberspace is considered as a national asset, and nowadays XML is heart of many technologies. You take for example web services, service oriented architecture, or even cloud computing. Everywhere XML is being used. Now web services vulnerabilities can be present in operating systems, or it may be present in network databases or web servers or application servers, application code, XML parsers, or XML appliances. That is because in all these cases XML can be used. Now whenever new technology comes, it also comes with new challenges, and those new challenges are nothing but old challenges plus new challenges. Let's say for example consider SQL database. So SQL database can be attacked with injection attacks. So when XPath came, so there also you can file, there also you can use injection attacks. So XPath injection attacks can be used. But since XML can also be used with web servers or web services, it comes with new challenges related to web services. So present threats also exist, plus new threats will also come because that new technology will still be emerging. So that's why it's going to come up with new challenges. So what we had tried to do in our application was to secure the web resources from XPath injection attack using modular recurrent networks. So modular recurrent networks are nothing but we don't use a single network. Instead, we use multiple neural networks, and the results of those neural networks are combined to get the result. So this is being done to get the faster result. Now the proposed solution uses the modular recurrent neural network to identify and classify a typical behavior in user input. So in next slides, we'll see what is a typical behavior in user input. Once the atypical user input is identified, the attacker is redirected to false resources to protect the genuine resources. Now what we had done in our solution was we developed a new validation technique, that is count based validation technique. So we'll explain in detail the entire algorithm on which this count based validation technique is based. We already know that there are validation techniques for user input. For example, you can use string matching or you can use regular expressions, but we are not using those two methods. Instead, we have developed our own count based validation technique to validate the user input. Now let's consider this example where it demonstrates how XPath injection attacks are being performed. Now you can see here this is the XML file where username, password of a user and account type is stored. Now this is how the line which is shown in blue color shows what should be the legitimate input. Now you can see here username is Gandalf and password is exclamation C3. So this is a valid input and this is what is expected from the normal user. But if he is a malicious user, he will craft a malicious input. For example, you can see here it shows or 1 equal to 1. Even password is shown or 1 equal to 1. This is nothing but the example of injection attack. So here Boolean operators are being used to design attack vector. So this is the input given by the malicious user. So definitely this needs to be handled. Now SAPEC on XPath injection. So SAPEC states different factors related to XPath injection attack. So you can see here there are few important factors. Now for example, what should be the attack prerequisite? It is XPath queries and unsanitized user controllable input. Now what is the typical likelihood? Exploit is very high, but attacker skills are very low. So that's why. So these two important factors, for example, typical likelihood of exploit and attacker skills low. These two are very important indicators, and that's why it becomes very important to handle XPath injection attacks. So of course there are other uh, parameters are also listed. Now there were several papers which we had reviewed. Now the first one is mitigating XML injection attacks through strategy based detection system. So in this paper ontology was built, a strategy based knowledge to protect web services from XML injection attack and to mitigate this 0-day attack. But there was a problem here. The problem here was that attack input was automatically added to the ontology database. So as the number of attacks in the ontology database increase, the technique would result in increased response time. So it was taking more time to respond to the attack. In the second approach, that is the effective detection of SQL or XPath injection attack. So here it was based on XPath and SQL commands learning and posterior detection of vulnerabilities. So by comparing the structure of commands issued in the presence of attacks, to the ones previously learned. So in this, the results were not promising since the workload generation took few seconds of time, but the learning phase took few minutes of time. So the overall time taken by the detection process was approximately 15 minutes per operation, which is not at all acceptable with respect to computing. Then similarly in the next paper, a learning based approach to secure web services from SQL or XPath injection attack. So in this approach is to learn valid request patterns. So then detect and abort potentially harmful requests. So here authors achieved 76% of accuracy, but more uh, accuracy can be achieved by implementing other techniques. So in our application, we achieved almost 90% of the accuracy, so which is 14% more compared to the existing approaches. Then next, in the last paper, preventing XPath injection vulnerabilities in web applications was discussed. So here XPath expression scanner was integrated with XPath expression analyzer to validate XPath expressions. Here also the response time was not promising compared to the earlier approaches. Now there were some other papers where they had used neural networks. So in a theoretical framework for multiple neural network systems, where general instance of multiple neural networks was strictly examined by Mike Shields and Matthew Casey. But the problem here that they use arbitrary number of networks to perform complex tasks, which results in improved performance. Now the concept of multiple artificial neural networks was used for long-term series prediction, where prediction is done by multiple neural networks at different time lengths. So here the authors showed that the multiple neural network system performed better compared to single artificial neural network for long-term forecast. Then in third, Anand R and his co-authors, they discussed a model neural network to reduce k-class problems to a set of k2 class problems, where each problem was dealt with separately trained network to achieve better performance compared to non-modular networks. So these three papers show that we can use neural networks for cybersecurity. So this was the reason for us to select neural networks for development of our deception tool. Now, what are the research gaps or the gaps identified? So the neural network approach to identify and classify atypical behavior input. So the study showed that the different approaches to handle XPath injection attacks. It also showed the and methods applied and their disadvantages. So we can conclude from the study that neural networks were not applied to detect XPath injection attacks and existing results are not promising and wherever they have been applied. So the study showed that how modularity in case of neural networks helps to achieve improved performance. So modular neural networks have been applied to cybersecurity, particularly to detection of SQL or XPath injection attacks. So the main outcome of the study of this literature is that we can use neural networks for cybersecurity to handle XPath injection attacks. And to improve the performance, we need to improve the modularity in case of neural networks. So this is the proposed architecture, what we had proposed. Now, if you observe here, there are three tiers. One is presentation tier, business tier, and the data tier. In presentation tier, we have user interface where user will enter the input and all communication will takes place with the help of HTTP protocol. Now, at the business tier, we have a web server which receives the data, which receives the request. Then at the data tier, we store the data. Now note here that at the data tier, we have XML document instead of SQL database. So that means we can use XML document for storing the data, and we can write or we can use a web service to access the data and give the response to the presentation tier. Now on the left hand side you can see there are a few examples for valid inputs, malicious inputs and invalid inputs. For valid inputs we have email ID, mobile number and some alphanumeric words, which is a combination for any valid username. Then malicious inputs are like, you can see here some injection attacks are used, so user or some boolean operators have been used and some undesirable characters have been used. The next, some invalid inputs are very large input string, then string with special characters, string formed from different character set. Now the goal of specifying invalid inputs such as very long input string is to generate some error messages. Whenever system generates some error messages, it provides some information of the system. For example, what is the operating system used, what's the version of the operating system used, what's the server. So some details can be exposed. So this information can be very useful to the attacker to modify his attack vector. So this is the algorithm which we had used, and all this has been completely implemented in Python. So this is how our count based validation technique works. Now in the first step we scan the user input, then in the second step we determine the length of the user input, for example how many characters are there in the user input. Then third step is very important, we count the frequency of every character in the user input. Now note here that in the class we have specified what are the characters which are allowed. Okay, now in table 4, that is in the right bottom corner, we have specified all the special characters and the threshold. That means, for example, if you are using a single quote, it can be used only once because some names may consist of single quote. Then double quotes 0, dot only 2 we are allowing. So similarly, for every character the threshold is being specified, and based on the threshold we have assigned the error code. Now using this error code we are going to decide whether it is a valid input, malicious input or invalid input. Now in the fourth step, if the frequency of the character is below the threshold value set for that particular character, then set the error code to 40. So if it is below, then you should set it to 40. So 40 means valid. So you can see it in table 2. Error code 40 means valid, error code 400 means invalid, error code 4000 means malicious. Then next, else if the frequency of the characters is above the threshold, the value set for that particular character set in table 4, then set the code to 4000. That means it's a malicious input. Else set the error code to 400, that means it is invalid. Then next, build a recurrent neural network 1. So as we have discussed, we are going to divide the neural networks into multiple neural networks. So I am going to train my first neural network, so which consists of 50 neurons with a hidden layer as the LSTM neural network and output layer as the softmax. Then next, use resilient propagation trainer to train the network using the training dataset created using the error codes in table 2. Now note here that this is the table set. So there was no dataset available, so we generated a synthetic dataset randomly with the help of a script. So that was used to train the neural network. Now use the test dataset created in real time to validate against the training dataset. So we knew few of the attack vectors, so they have been used here. Then next, build the second recurrent neural network again with the same configuration as of the first neural network. Then next, use RProp network to train the network using the training dataset created using the number of login attempts. Now note here that in the second case we are training it on the number of login attempts. So first 3 login attempts will be considered as valid, then more than 3 login attempts will be considered as malicious. Then next is use the test dataset created to validate against the training dataset. Now if the training error and test error of both the networks are 0.0%, then finally classify the input vectors based on the output of both the neural networks in table 3. So there's a table on the next slide. So for example, you can see here, so there are 2 neural networks and each neural network generates some input, some outputs. So the combination of those outputs will be used for our final classification. For example, if output of both the neural networks is valid, then only it is considered as valid. If one of them is malicious, then final classification will be malicious. If one of them is invalid, then it will be considered as invalid. In case of malicious and invalid, it will be considered as malicious. This is how final classification is done. So coming back to the previous slide again, so if the user input is successfully classified as valid and found in real XML file, then return the message as login successful. Else the user input is classified as malicious, then return the contents of the fake XML file. Else if the user input is classified as invalid, then return the error message. Else repeat the steps from 8 to 3. So I have screenshots, so I will show those screenshots in next few slides. Now tools used where we had used PyBRAIN package, which is the artificial neural network package. Then it was used for neural networks. Then web services framework was BottlePy web framework. Then web servers used was Apache. Web browsers were used Firefox and Conqueror. Scripting language Python was used along with NumPy and Matplotlib to plot the graphs. So it was tested on Fedora Linux 14, and the configuration was Intel i3 processor, 3 GB RAM. So the same environment was used for development and testing. So system may also be deployed on machines with lower configuration and on different platforms. Of course, it is also possible with higher configurations. So PyBRAIN is modular machine learning library for Python. So it's short for Python based reinforcement learning, artificial intelligence and neural networks. So you can download and install it using these commands. And there's a tutorial available on this website. You can also visit pybrain.org to get more information. It's a very useful library. Then Bottle is a micro web framework for Python. So it's distributed as a single file, just one single file. You can directly include it and start using it. So any other web framework, it has features for routing, templates, utilities, and server. So it does not depend on any external libraries. That is the advantage. So you can find out more information on following website and on the repository. So these were our results. So we had got result in terms of true positives, true negatives, false positives and false negatives. So in true positives, you can see here we are considered 3 parameters here. One is number of epochs and modular neural network, then second one is single neural network. Now you can observe these 2 columns, that is modular neural network and singular neural network. So result for modular neural network was better compared to the single neural network. In case of single neural network, the result was highly inconsistent, but with respect to modular neural network, it is highly consistent. As the number of epochs increase, still we are getting the consistent result, whereas that is not true with respect to single neural network. So we have almost got 90% accuracy with respect to true positives. Then similarly with respect to false positives, you can observe the same thing here. We are getting consistent result with respect to modular neural network, but we are not at all getting consistent result with respect to single neural network. So next, comparison of true negatives. Again, we have got 90+% results. Again, results are consistent with model neural network here. Even results are same consistent with false negatives are consistent with model neural network. Now response time. So you can also observe the response time here. As the number of samples increase, the time required for model neural network decreases. But the ratio is 1:1.5. For example, if single neural network takes 1.5 seconds, then model neural network takes only 1 second. Now you can also observe the result, average detection rate, including an outlier and excluding an outlier. With respect to model neural network, if you include the outlier, it is 84.2%, and here it is 46.5%. If you exclude an outlier, it is 93.5%. Whereas a single neural network, it is 51.6%. So it clearly shows that if you use model neural network, the results are better compared to single neural network. Now coming to the snapshots, you can see here there are two files. One is fake data.xml file, that's the first file. Second one is the data.xml file, that's the second file. Now in fake data.xml file we have the fake data, in data.xml file we have the real data. But if you observe the structure of both the documents, it is same. But the data is not genuine in fake data.xml file. Now this is the initial output of our application. So we have got few sections here. First one is the login form, then second one is the output of neural network, then third one shows the analysis of results, then fourth one shows the log of attacks. Now the first case where we are demonstrating the valid input scenario, you can see here we have entered valid input and valid password. When we click on submit, it is displaying the message that login successful. So it is also displaying some results related to the neural network, and you can see here it shows what inputs were entered, then what were the port numbers, remote addresses, request methods, browsers, operating systems were used by the user. So this helps us to gather more information about the attacker or a user. Then next, you can see here in the next case we are demonstrating malicious input scenario case where user is entering malicious inputs. For example, instead of valid user input such as mobile number or email ID, he has entered malicious inputs. Okay, so when he enters malicious input, it displays fake data. So it is not redirecting him to real data, instead it is redirecting him to fake data. Now the purpose of displaying fake data is that the attacker may feel that it's a real data and he keeps on trying to enter into the system using this data. But when he logs in, you can also further configure a system where user enters the fake data. It may redirect him to some virtual machine or some trap where he'll keep exploring, where he'll be busy in exploring that system, while simultaneously the security person may try to protect his resources. So now you can see here he has used fake data which we had displayed, and now it is showing login successful. So just for our understanding, I have added the term fake. Okay, so conclusion is that our solution offers improved security or existing methods by misleading attackers to false resources and custom error pages. So it also shows that system accepts legitimate input, although the user input may contain some special characters, and rejects some truly malicious inputs. So our solution combines modular neural networks and count-based validation approach to filter the malicious input. So it has also resulted in increased average detection rate of true positives and true negatives, and decreased average detection of false positives and false negatives. And final conclusion is that the security systems may have to be successful every time, but the attacker has to be successful only once. So the main goal of the deception is that to detect and prevent advanced attacks using minimal resources. So I thank Sammy for providing me an opportunity to speak at PyCon Hong Kong 2020. Thank you.
Uh,